In 11.2, we talk about parabolas. So, of course, we've already we spent one section back. I want to say it was like 9.5 or maybe it was 9.6, where we graphed parabolas, using the quadratic formula and that sort of thing. Going to go a little bit further here. Think of it a little bit differently. So we're going to get the standard form of the equation. Okay, so we are familiar with the general form of a parabola, right? Y equals ax squared plus bx plus c. That is what we graphed way back in chapter 9. Turns out there's another way to think of the formula. It's called the standard form, sometimes referred to as the vertex form. And it looks like this. Y minus k equals a times x minus h squared. And you see the similarity between this and the circle. We see the x minus h squared. Well, that exact piece was in the equation for the circle. Here, this part is not squared, just the nature of the parabola. The y isn't squared there, only the x, right? So, but we do have the y minus k. On the third part, you see the a. That is the same value that it would have been back here. That number actually stays the same from one form to the next. Why do we call this sometimes the vertex form? Well, it turns out HK is the vertex, just like HK is the center of the circle. It's like the focal point where everything is symmetrical about. For the parabola, everything is symmetrical about the vertex. And so, again, that's why we give it the same letters, H and K. All right. Also, we already know what the A tells us from before. Maybe you remember that tells us whether it opens up or down. If A is positive, then our parabola opens up. If A is negative, the parabola opens down. All right, we're going to look at our first example. We're going to be asked to graph. I thought there might have been something else on this page. Here are the steps to graph. When we graphed parabolas in the past, we had 5 steps. Well, it turns out we only need 4 steps if our equation is in the vertex form, because we can so very easily identify the vertex. That saves us some work. So step number 1, determine which way your parabola opens. Step 2, determine the vertex. There won't be any number crunching here at all. You can just look at it. Boom, what's h, what's k, right? The last 2 steps are the same. Find the Y-intercept, or maybe there's more than one intercepts. Find the X-intercept or intercepts, and that's how we will go about graphing. All right, now let's get to an example. Similar instructions to what we saw back when we were working with circles. We're given the general form. We are to write this in the standard form, and then of course we'll identify all those pieces and how it opens, where's the vertex, that sort of thing, and then we'll be able to graph. Okay, part A, y equals x squared minus 2x plus 5. So our goal is to put this into the standard form like so. Very similar steps to the way we did it with circles. We're going to need to complete the square. Also at the beginning, we're going to need to move that 5 to the other side. That's going to start to work towards the k, and then what's left with the x's, we're going to start to work towards this. So here's my steps. Just to re-emphasize that, we're going to group the x's. Really, what that means here, we're just going to make sure, we're just going to keep them here on the right side. We're going to move the constant. That's really the only thing to do at the beginning. So we've grouped, once we subtract that 5 over, well, we've moved the constant, and there's our grouping. We don't need parentheses here since they are the only thing on that side. Okay, so we make it look like y minus 5 equals x squared minus 2x. And what's next? Well, of course, we're going to complete the square, transforming it into this style we see down there in the standard form. Okay, complete the square. So x squared minus 2x. So I look at the 2, divide it in half, square it. We're really going to see this pattern a lot. We're going to complete the square a lot in this chapter. Well, what would that mean? 2 divided in half is 1, squared is 1. So we add 1 to complete the square. And then, kind of same philosophy as always. If I up and just add 1 here, I need to balance that out on the other side. So I need a plus 1. And we're almost there. I'm going to simplify this, and I'm going to factor here. And that does it. Y minus 4 equals x minus 1 quantity squared. I've got the standard form. Okay, looking good. Now it's time to graph. Well, I don't have enough information just from that equation. I need to get some more out of it. So let's go through them. And I see I have some work over on this side. Let me cover that up. First, which way does it open? Well, we don't see it, right? But the A is here in front. It's a 1. A equals 1, so we know this will open up. Next up is the vertex. There's no work here. We can find it straight off of our equation, which is why it gets the name vertex form. Remember, it's always the opposite of what you see. The x-coordinate of the vertex is, it matches with the x. So if I see minus 1, I know the x-coordinate of my vertex is positive 1. The y-coordinate comes from the y. Well, if I see minus 4, my vertex is positive 4. Okay. Now, the two pieces that need a little bit of work, a little bit of algebra, the y-intercept. All right, the y-intercept, if you will remember back from chapter 9, that means we need to set x equal to 0 and solve for y. So I'm going to put the 0 in for the x, like so. This one won't take too long. 0 minus 1, negative 1 squared ends up being positive 1. Add the 4, and we got it. Y equals 5 is the y-intercept. Or you might say, more technically, it's the 0.05. Okay. Over here on the other side, we're going to look for the x-intercept. Well, if you remember, that means we need to set y equal to 0. It's always the opposite thing you set to 0. So we're going to put in a 0 right there. 0 minus 4 equals x minus 1 squared. And we need to solve for x. Okay, well, 0 minus 4, let's just call that negative 4, equals x minus 1 squared. And at this point, since I have a square, hey, let's just take the square root of both sides. Okay. And I see I forgot my plus minus. Take the square root of both sides so it cancels on this side. Square root there, and I don't forget that plus or minus. Hey, wait a second. Square root of negative 4. That would be an imaginary number. Well, we don't graph imaginary numbers, so that tells me there are no x-intercepts. If I get an imaginary, that's nothing we're going to graph. There are no x-intercepts. Okay, I got all the information. Hopefully you have this written down. I'm going to go ahead and grab my graph paper. Okay, just getting settled here. Sorry about that. Thought I was ready. So turns out I need to create an XY plane on my graph paper. Didn't have it ready on this one. Aha, all right. Something like that. Okay. So we found that this thing opens up. All right, great. We found the vertex is at 1, 4. So 1, 4 is right there. And it's going to go upwards, okay. We found the Y-intercept to be 0, 5. Well, that's just 1 point up right there. There are no x-intercepts. It never passes through the x-axis. Well, that makes sense because it's going to go up. It never passes through the x. Well, this isn't a whole lot to work with. But if you will remember, there is that imaginary line going right down the middle through the vertex called the axis of symmetry. You don't necessarily have to draw it, but use the axis of symmetry to get the point symmetrical to your y-intercept here, and at least we'll have 2 points to work with. Still, it's not very much, but that's okay. We can get a good idea of this graph. Make sure it's nice and rounded and curves upwards. You know, steeper the further out you get. That'll work pretty good right there. Okay, let's stop this video here. We're going to go further in the next one.